welcome to my YouTube channel at Akeem. We have another question to solve today, and the question we are solving today is on theory of logarithm. And if you look at the question on the board, it's somehow scary, but not. Don't worry, we are going to do justice to the question right now. But before we go ahead solving the question, don't forget to subscribe to my channel at Akeem Ola. You can also like and share my video. You can as well comment on this particular video. I will appreciate if you can do. Now let's go solving the question on the board. We have log 4xx plus log x all over 2x is equal to 2. There is something we need to consider here. If you consider the base and the power, you will notice that the base and the power for the two equation here, for the two terms here, the powers are the same. Since the powers are the same, we can actually make the base to be the power, and we can make the power to be the base. If we are going to do that, then we are going to consider the law of logarithm, as in this law, log AB. If I want B to become A and A to become B, that means I'm going to have 1 all over log B A. So if I have something like this, I'm going to observe this here. So if I should do that here, I am going to have 1 all over log x 4x, then plus 1 all over log x all over 2 is now equal to 2. Now I have something like this. Then you will observe that since the days are the same, then we can also apply the product law, the product rule of log here. Then we can apply the division rule of log here. If you apply the product law, you have something like this: log 10 AB. This one here will become log 10A plus log 10B. Then if you have something like this, log 10A all over B, this one will be equal to log 10A minus log 10B. So now, if you are going to observe all this law here, so we are going to have something of this nature. 1 all over, this one now will now be log x4 plus log x. Then we have our plus here, the 1 all over log x minus, division will change to minus, just like what we have here. So we are going to have log x 2. Everything is equal to 2. Now we have this. Then don't also forget another theory, another law of log that states that when the base and power are the same, you have AA, then everything will be equal to 1. So we are going to apply this here and also here, because here we have log xx, this one will be equal to 1, while this one too will also be equal to 1. So we are going to have something of this nature: 1 all over log. Of course, we can simplify this 4. 4 is 2 raised to power 2. Then we have plus 1. Then plus 1 all over, this one will also be 1 minus log s2. Everything is now equal to 2. Then another law of log, when you have two powers, something like this, log A, and we have B, C. This one now will now be equal to the C, now will now serve as the coefficient of this log. That means we are going to have C log A B. That is what we are going to observe here. If you observe that here, we are going to have 1 all over 2 log S2 plus 1. Then this one now will now be 1 all over 1 minus log S2 is equal to 2. Now that we have something like this, then you will also observe from this equation that log s2 is common to both sides. That means I can write let A is equal to log s2. If I should do that, the equation now, everything will now come to something like this. 1 all over 2a plus 1. This will now be 1 all over 1 minus a. Everything is now equal to 2. As you can see, we now have an algebraic fraction on the board. And the only way we can simplify an algebraic fraction is by finding the LCM of the denominator. Or we can even do the cover method or the cross line method. If we should continue from here, that means we are going to have this one will multiply this one will also multiply this. Then the LCM of these two now, we are going to cross multiply it to multiply this particular two. So if we should do that, we are going to have 1 into 2a plus 1, then plus 1 again into 1 minus a. Everything is now equal to 2 into 2a plus 1, another bracket 1 minus a. Simplifying the left hand side, simplifying the right hand side, we have 2a plus 1 into 1 minus a. That will give us 2a minus 2a squared plus 1 minus a. Going further, this one and these are the same. Going further, we are going to have a minus 2a squared plus 1. If you simplify this, the one we have no effect on what is inside the bracket. That means we are going to have 2a plus 1 plus 1 minus a is equal to 2 into a minus 2a squared plus 1. So I can clean this now and simplify further. If I should simplify further, let's open the bracket. We will have 2a plus 2 minus a. Okay, we can still simplify this further. 2a minus a will surely give us a. Then plus 2 is now equal to 2a minus 4a squared plus 2. Now we can move everything to this side. And you know, once you move something from here to the other side, and there is an equality sign here, the sign will change. That means we will have 4a squared minus 2a plus a that is already there. Then minus 2 plus 2 is equal to 0. So from here, we are going to have 4a squared minus 2a plus a will surely give us minus a. Then minus 2 plus 2 will give us 0. So we can now equate everything to 0. So from here, a is common to both sides. So we can take it out. We have a into 4a minus 1 is equal to 0. This now implies that a is equal to 0. Or 4a minus 1 is equal to 0. This now implies that a is equal to 1 all over 4. So we have a is equal to 0 and a is equal to 1 all over 4. But if you check very well, a is not part of the question, part of the equation given to us. We are the one that actually introduced a into the question. So we need to go back to the relationship between a and the alphabet that is used in the question. And the relation, this is the relationship. We have let's, or I can write, since a is equal to log x raised to the power of 2. That means I will now consider the value of a one after the other. I can write when a is equal to 0. Let's try and simplify that. When a is equal to 0, that means I'm going to have log x2 is equal to 0. The next thing I will do, I will remove the log sign. If we remove the log sign now, this base here will be raised to the power of 0. That means I'm going to have x raised to the power of 0 is equal to 2. And x raised to the power of 0 is 1. This statement is totally wrong. 1 can never be equal to 2. This is a false statement. Automatically, when a is equal to 0 does not exist. We are going to ignore that value of a when it is 0. So I can just write it does not exist. So we can now shift our attention to the other value of a. So I can now write when a is equal to 1 all over 4. That means I'm going to have log s2 is equal to 1 all over 4. Remove the log sign. If I remove the log sign now, the base will be raised to this power, and I'm going to equate it to the power here. That means I'm going to have s 1 all over 4 is equal to 2. What will I do? How will I simplify this? I have x raised to the power of 1 all over 4 is equal to 2. The only way I can simplify this now is by raising both sides here and here to the power of 4. So I raise both sides to the power of 4. Raise this to 4. Also raise this one to 4. If I should raise it to 4, the 4 here we cancel. So we have our x now will be equal to 2 times 2 times 2 times 2. So x now will now be equal to 16. So x will be 16 for this equation here to exist. So as you can see, solving a question on logarithm, on theory of logarithm, involve the uses of the logarithm law. So we combine so many laws here for us to solve this particular question. We are going to stop here for now. Then we'll take it off from here next time. Don't forget to subscribe to my YouTube channel at Akeem. You can also like and share my video. You can as well broadcast my you can as well broadcast my channel to the people around you. Thank you for watching. God bless you. God bless me. We move.